Section 7.1 is radical functions. First of all, we want to be familiar with our symbol. We have the square root, which is our radical. That's our radical symbol. We have the number underneath it. It's called the radicand, and the value right here is called your index, and it's going to be a very important component when we're making decisions later. If it is not showing, it's a known to. That's the statement here. Couple of things that are helpful. Square root of 0 is 0. Next, when the index is odd, that means when this number right here is odd, it's okay for the radicand to be negative. So um, that can be okay. When the index is even, it is not okay for the radicand to be negative, and it gives us a number that is not going to be a real number. So we have some circumstances and some helpful hints to keep in mind right there. Next, we're going to go through and mark these. Square root of 100 is 10. Okay, right now we're going to do square root of 100 is 10, and this negative sign is just left out in front, so we get this. Next, we have the square root of 100. When this negative, remember this index is even since it's an known 2. When it's an even index, you cannot have a negative radicand, so this is no real root. No real root there. This, when we have a fraction, we take the square root of 100, which is 10, and the square root of 36 is 6. Now we need to simplify this fraction, and we're going to get 5/3. Next, we have the cubed root. Our index is odd, so we want to know what number times itself 3 times is going to give us 64. So we want to know 4. So if I did 4 times 4 times 4, it gives us 64. So that's what it's asking when it's saying the cubed root. Over here, we can do this negative radicand because this is an odd number. The index is odd, so therefore that can work. So negative 3 times negative 3 times negative 3 is going to give me negative 27. So the cubed root of negative 27 is negative 3. And the cubed root of 8 is 2. So our answer is negative 3/2. Next one, we want the fourth root of a negative 16. Well, since our index is even, we cannot have a negative radical, so a negative radicand, so this one is no real roots. Okay, first thing we want to do is we want to recall this information right here. We know that this is a known index of 2. If my index matches my exponent, then all we have left is just my variable, because a square root undoes a square, just like a cubed root undoes a cube function. A fourth root undoes a variable raised to the fourth power, and so on and so forth. So if I can rewrite this next one, since my index is a known 2, I want my outside exponent to be a 2. Now, I can't just lose that. I need to have all 6 of them there. So 2 times what gives me a 6? 2 times 3. So then when this square root undoes this square, we're left with x to the third. So we look at that in the next problem. My index is a fifth root, so that means when I rewrite x, I want it to be something to the fifth power. Well, I have to account for 10 of them, so 5 times what gives me 10? That's going to be a 2. So the fifth root undoes the fifth power, and I'm left with x squared. Okay, and the next one we have square root of 9 is 3, and this known index is a 2. Since this index matches that, I have just an x come out. Okay, square root of 16 is 4, and if I was to rewrite this, this would be 6 to the y to the third squared, which just gives me y to the third, applying the concept above. Okay, this has an index of a 2, this is a square, so we just get x minus 5 on this one. Okay, the last thing is function notation. So if it says if I plug 0 everywhere x is at, so into that problem, so if I take this and I say square root of 2 times 0 plus 3. Well, the square root of 2 times 0 is going to be square root of 3. And the next one, if I take the square root everywhere x is at, I'm going to put a negative 3 this time. Which that's going to give me square root of negative 6 plus 3, which is going to give me the square root of negative 3. Since this is an even index, we cannot have a negative radicand. This one is no real roots. And my last one, if I'm going to plug a 3 in everywhere x is at in my function notation, and then I'm going to have square root of 6 plus 3, which is equal to the square root of 9, which is equal to just 3.